Hello, and welcome back to Learning with Lee. In today's episode, we are going to take a look at how to access elements within a string, as well as then update those elements, as well as update a string itself. So, let's begin looking at how we can actually get specific items within a string. So, I've written this function in order to demonstrate a few key points. The first thing is that there's a couple of different functions, and one of them happens to be just using the subscript operator, that we can end up using to access specific elements in this string here. So if we head on up here, you'll note that both of these end up getting the same value out of this s right here. So there ends up being no real difference for either of those that we can at least immediately see between using the subscript of the two brackets here, as well as then using this at function or at method. And the major difference is that the difference you can see down here between this try and catch over both of these. In each one of these, I'm trying to access an element. It happens to be outside of the scope of this string. So it's some element that is beyond this string. It exists somewhere off to the right here, and we don't know where it is, but, well, technically, if we knew where this was in memory, we could take a good guess at where this is in memory. So the problem then is that what happens if we try to access or modify an element in that manner? Well, if we just try to access it, you're going to see down here, we end up getting, and it is the first one here, we end up getting this TM trademark out of it. And that's because it's just printing whatever it finds at that location in memory. So it could be anything, we don't know what it is because it has to deal with something else. Note that this could actually crash your program in case that memory does not belong to you. As well as then if I tried to update that memory, that could also cause some serious issues because of the fact that it would end up basically breaking the program. However, that's where the value of at comes in. If you try to use at for something that happens to be beyond the length of your string, it's going to throw an exception. As you can see on this line here, it ends up reaching this catch statement here. That ends up allowing us to make certain that we actually don't try to affect anything that we don't have access to. However, that does come at a minor performance cost, because it means that within at, it has to do a couple of comparisons. It first has to check that the number within there is 0 or greater, as well as then it also has to check that the length of that, or the size of this, is less than the length of this string here. Unfortunately, as we're going to see in a little bit, down here you can see there's this size function, so it's going to end up basically having the ability to access some member variable to get that size. And you remember how we did that with linked lists, where we tracked the number of elements in a list. So that we didn't have to iterate over the entire list to figure out the size of something every time we wanted to do it. However, because the fact that it does that comparison with every time at is called, if you're using at in a more high-performance algorithm or the like, you're going to suffer some performance as opposed to using the subscript notation, which is just going to try to get that spot in memory. So that happens to be a valuable thing to consider, that there is that performance hit with using at, and that's the main reason why you would end up using the subscript notation as opposed to at, is in case performance is an issue, or even if you know for a fact that you're not going to be outside of the size of your thing. So if, in this case here, I wanted to print it one character at a time here. If, for example, I wanted to do something such as get that and then put a space between every character, then I could do something like this, and then if I run it down in here, you can see how now it has a space between every character, and ends up doing that fine for us, but we can end up using subscripts safely here, because we know we'll never be more than the size of our string. One of the things that you might actually want to consider, and this is something I haven't gone over too much yet, but that's actually caching the result, just because it sounds like several different words. It's spelled C-A-C-H-E. Basically, it means to store something, but basically caching this value, so in case I just go with something like size underscore t, and size t is just another term for an unsigned integer in general. So let's just call this count, and it's equal to that. And then we just go for I less than count, because the major reason why we would end up doing this is that otherwise what ends up having to happen is that every time we go through this loop, size has to be called, which means it basically ends up having to marshal the parameters, which in this case aren't any, but it has to basically set up that function and then get the stuff out there. So it's slightly less efficient than just accessing a spot in memory that already has a size t in it. It could be optimized by your compiler so as that you don't have to worry about that. However, it is one of those things that it occasionally makes sense to not want to have to rely on your compiler doing that optimization for you. So you want to just store it in here. So all you have to do is you're basically going, okay, compare this int to this int, or more accurately, since they're size t, they're unsigned int. And you can see here, it's a 64-bit unsigned int. So that is one thing that you might want to do, and it's very common that you'll see with different algorithms that go over something. And we'll get into things such as for each loops in the future and some of the different things like iterators in the future that can also be used. However, for this particular case, the value here is that it allows us to be a little bit more efficient than having to call a function every single time and having to set up that function. And then also, because Gettysburg, this particular string, might be in a significantly different location in memory, it might mean that I have to load in stuff that currently is sitting in RAM onto my CPU, into its cache, in order to basically do that. And we'll get into that once we start dealing with operating system concepts and how memory works for why exactly that could be a problem. But it does make a lot of sense to end up caching this, and also because depending on what language you're dealing with, depending on what type of collection you're dealing with in here, in this case it's a string, but it could be any number of different standard collections, size might end up actually having to iterate over the elements in there, depending on how it happens to be constructed. So that is all worth considering and all important to note. So this is, in general, what you'll very often see for these type of loops. Then you can also use the subscript as well as @ to update something, as we can see then down here, where I first put in z and then put in this little blank space right after it in these two lines here. So you can use it for both of those, and once again the same rules about efficiency apply, but it is important to note that either one of these two methods, well, by which I mean means, not as in methods and functions, but either one of them can end up being used to actually do this operation. Then you can also do things such as, in case you want to use the equal sign to copy from one string into another string. So you can see down here, here's our copy. If I update that copy and then output both of these, you'll note that only the copy gets modified. So this ends up being a deep copy. To be fair, in case your compiler and implementation is done well enough for this, and the way in which it's supposed to be done, is that basically this copy is a shallow copy. Basically, it's a pointer to that same string until you have any operation that modifies this copy. So initially, it's just going to go, okay, I want this guy to point to this guy. And then when I go down here and do this assignment operation here, it's going to go, okay, now I want to make a deep copy of this. And it happens to be a bit more efficient that way, especially in case you end up dealing with things such as passing it into different functions that may not pass it as a reference, but might end up wanting to just pass it around a bit before they actually end up doing any modification, so you don't have to copy it with each layer of function that you're calling. So it is important to consider that for it, and it is a good and efficient way to do that algorithmically, but that happens to be something we can leave alone for now, other than the fact that it is important to note that the copy and the original do not both get modified when you end up updating the copy. As well as then if I updated the original, so in case I did copy this guy here, put this here, and then if I build this and run it, you can see now their copy line is clean, because basically we have this copy here, then we also have this copy here, and then we output this one, so we wind up with only the original being modified. So that is an important thing to note. Then, down here, you can also end up appending on strings and characters by using plus equals. So not only can you use equals like we're doing for single elements, or for strings by themselves, you can also then append on either strings or characters to your copy. And as you can see down here, it ends up working correctly, ends up outputting it correctly. And that really is all that you need to understand about the assignment operations, how to access specific elements within there. In the next episode, we're going to be dealing with substrings and searching, similar to some of the stuff that we did with strcmp, as well as some of the other stuff that there was in cstring. But those are all things that we'll cover in the next episode. So maybe spend a bit of time messing around with strings, seeing how you can copy from one to another, manipulate them, and just get comfortable with this between today and the next episode, and I'll see you then. So thank you very much for watching. Have a wonderful day.